Okay, so this lesson here, I like to think of it as a summary lesson. Okay, so I've been saying this for the last couple of classes. The first two lessons we talked about a unit circle, the idea of there being the four quadrants, and you can plot triangles in, usually it's two of the four quadrants. That's typical, right? And then the last two lessons I talked with you about the shape of graphs, the idea that a sine wave goes up and down, all those different shapes, and both of those kind of tools in your arsenal can be used to do what we're going to do today. I need you to be able to solve. Okay, that's kind of the main concept, is how to solve an equation. And I just started with this slide on here. You guys remember the definition of a function? I know we haven't used it in a while, but what is a function? Well, a function is an operation where a number is given as an input and you get a single number returned as an output. Like, for example, here's a linear function. If x was 1, y would be 3. Or here, if x was 1, y would be 6. Right? If x was 2, y would be, you know what I'm saying? Like, you can always plug in a value, right? So what I want to talk about now is, well, just let's summarize. How do we deal with this when you have sine, cosine, and tan? Now, I think you asked me yesterday, is there a difference between x and theta? And really, there isn't. In all of these equations, we usually go with x, but in the sine, cosine, tan equations, often rather than seeing x, you'll see theta, but it literally means the same thing, okay? So if I tell you what a theta happens to be, that means I'm giving you an angle, you're looking for what that value is. So let's try some examples. So the two types of solving. What if I tell you what the angle is? Well, if I tell you what the angle is, there's only one answer. For example, let me show you this one in a couple of different ways. Say I want you to tell me the sine of 30. Well, we now know what a sine graph looks like. Here's a sine graph. Where would 30 be? I don't know, as I go along the axis right around here, 30 would be somewhere along the ways here. Let's say that's 30 right there. Well, then sine of 30 gives you back one y value answer. There's one answer here, right? So one of your options is just find it on your graphing calculator. So, graphing calculator. I mean, literally, you could even just do sine of 30 right here. Why not do that? Just make sure you're comfortable flipping between radians and degrees. So look, sine of 30 is 0.5. That's one way I could solve it. But there's more. I could go to y equals, and oh look, sine's already on that. That's perfect. I could go to my sine graph, make my window go between 0 and 360. Here's my sine graph, just like I drew right there, right? And I could find the value as x equals 30, and it's, again, 0.5. Does that make sense? So there's two ways of solving the question. A third way of solving it would be, well, what if I made like a Cartesian plane around it? 30 degrees very specifically tells me which quadrant it's in. There's not 2 or 3 triangles I can draw here. 30 degrees definitely has to be sitting in this quadrant right here, right? And then hopefully you know the 30 degree, 60 degree triangle. It's a 1, a 2, and a square root of 3. And then you'd say, well, what's sine supposed to be? And then sine, according to SOHCAHTOA, is opposite over hypotenuse. So your opposite over your hypotenuse gives you 1 over 2, 1/2, 0.5. So there, 3 different ways of solving. Which is why I think yesterday I gave you that example of like hanging a picture on a wall. You could use duct tape, you could use a nail, you could put a hole in the wall and just shove the picture in there or something ridiculous. Like there's many ways of solving, right? And none of them is like the right or wrong way. I just need to enable you with different skills so that depending on whatever the diploma question is, you're able to say, oh, this would work. Okay. So anyways, that's the first type of solving. That one's pretty easy. If I give you the angle, you solve. So I got a whole bunch more of them to try. Why don't we do just a couple, and if you want to do more, we can do more later. So why don't we start off with the sine of 300? Well, we'll start simple. Okay, sine of 300. Well, option 1. Here's my sine graph. Calculate the value at 300. All right, I got negative 0.866. Okay. Now, if the question type allowed for me to go with a decimal value, that's fine. I can live with that, right? Like if it was a multiple choice question, that probably is enough. If I wanted to just do the sine of 300 right here, that also gives me the same value, negative 0.866. But what if it wanted you to give the answer as a root b over c? Well, then you can't do that, right? So you need another method. So then the third method would be the best. Where is 300 going to be? Which quadrant? Yeah, sitting down here, right? The reference angle here would be 60 because there's 60 degrees like left over. It'd be a 30 degrees right there. 300 comes all the way around like that, the one we're looking for. Okay, so then now this is a triangle you're expected to know. So hopefully over time you kind of just get better at knowing which one goes where. This is the 1, that's the 2, that's the root 3. Only that's actually not correct. I made a slight error. Good catch, Jamie. Yeah, negative root 3. Oh, and then last thought, we're asked for sine. So sine is equal to the opposite over the hypotenuse. I'm pretty sure that if I typed in negative, well, let's just do it, I guess. Why am I saying pretty sure? Negative root 3 divided by 2 is the negative 0.866 number. Do you guys get where I'm going with this, though? All 3 or 4 or however many methods I showed you there, they're all valid, but it just depends on the type of question. So if it had to be done in the a root b over c thing here, I guess a was negative 1, b was 3, c was 2. If you had to do it in that format, I don't think you can use your calculator for a couple of the methods. You'd have to know another option too. So, sound good? Okay. Why don't we jump down and do one of those crazy ones down here, like, say, the secant of 11 pi over 6. That one looks like fun. Okay, so right off the bat, let's try some of the original methods that I did on the other ones there. Like, let's just try to type in secant of 11 pi over 6. Right off the bat, I've got an issue. Where the heck is the secant button on the calculator? Well, there isn't one, but I could still do this. I would do the cosine of 11 pi over 6, and then I would make it go to the minus 1, because that takes a cosine, flips it into a secant. So that'll work. 1.005, but actually that's not right. Why is that 1.005 number not right? Because I'm still in degrees, yeah, so you gotta be careful on that. Ooh, go away, stop. Wait. Okay, so I got 1.1547. Let's get that. So cosine of 11 pi over 6, then to the minus 1 to turn it into a secant, I got 1.15. You're nodding. You're good? Okay. Again, if that's all that's required, drop dead easy. If that's all that's required, right? But you got to recognize that I need to teach you better than just that. So other options. I could get you to graph a secant graph. Again, it's not easy to graph a secant graph, but you could go cosine of x to the minus 1. And then since I'm in radians, I got to change my x max to 2 pi. One more thought before I go. Remember how the secant graph does like a U's all over the place? If I make my window size go from -1 to 1, I will see nothing. Because that's actually where that little gap right in the middle is, where it does like, you know what I'm talking about here? So I'd also have to change my Y window to be like, say, -5 to 5. Now I should see the little. Does that make sense? And then I just got to type in my value. So second, calculate the value of, what was it again? 11 pi over 6. And again, I got that 1.15 number. So, I mean, I got to be honest, I don't know why I'd actually pick that way of doing it compared to the first, but there's time and place where it may be useful, right? So, okay, but let's say we need an exact value. Right? Say they want it as a root b over c again. How do we do that? Well, then let's try to make a unit circle. Where the heck is 11 pi over 6? You're right, yeah. 12/6 is 2, and 2 pi is all the way around the circle. So if you really want to go through this exercise, you could say 1/6, 2/6, 3/6, 4, 5, 6/6, 7, 8, 9, 10, 11/6 of pi is sitting right there. Now that we know that 11/6 of pi is all the way around to there, we would know that a 1/6 of pi is the remaining little reference triangle. A 1/6 of pi is also 30. Good, you're catching on. That's awesome. And then you just need to know the sides of your triangle again. That is a, oh shoot, which way is it? I gotta draw it. I can't see it right now. That's a 60, a 30, a 2, a 1, a root 3. So the 60 goes between the 2 and the 1, and then the 60 goes across from the root 3, and that's a negative. Okay, you guys okay with that? I did half of that in my head. Last step, what is a secant? A secant is what happens when you reciprocal a cosine. Cosine would have been hypotenuse, no, adjacent over hypotenuse. We need the hypotenuse over the adjacent. So we need the hypotenuse over the adjacent. Still good? That still doesn't fit the stupid format they want me to write it in, though. Because they want me to write it as a root b over c. We're going to fix this. Yeah, if you multiply by root 3 on the top and bottom, it's called rationalizing. It would give you 2 root 3 on the top, and on the bottom, root 3 times root 3 literally is just 3. Okay, let's confirm that. So we're looking for 1.15, 2 root, oops, that's all right, 2 root 3 over 3, also the 1.15 number. Sound good? Sweet. Okay, now the unit circle works great in a lot of cases. And I think I've said this to you guys before. Sometimes kids hate trig because there's like no work. Right? Like I just did a bunch of doodling all over the page here, but like where's like the official show your work? There isn't any. The unit circle though, it fails quite harshly if the denominator of your fraction is not something that can be broken back down into an over 3, an over 6, or an over 4. Because it has to be in those multiples. If you want to do this last one here, I won't solve the whole thing, but if I want to do cotan 13 pi over 17, like 17 is not going to break up into something that's a third or a fourth or a sixth. You get what I'm saying there? So therefore, you know that triangle that has the 1, 2 root 3 or the 1, 1 root 2? If I can't draw that triangle, drawing a unit circle is pointless anyways. So the best I can do on this one, I can't get an exact value. We don't have the ability to with what we know right now. The best I could do would be to say, let's tan 13 pi over 17 to the minus 1. That's the best I could do. I could get you that value there. But because this is over 17, not 2, or not 3, 4, 6, or multiples thereof, by the way, right? Like, you could do 12s or 24s because 6 goes into them. But since 17 is prime, this is all you'd have. It's the best you could do. Sound good? Okay, next example. We'll move faster. Now, when you go the other way, what happens if I say not sine angle equals x, but what if I give you sine unknown angle equals a number and I tell you what it equals? Well, in this case here, this is actually really not a function in the same way because now there's multiple answers. Now there's the answer when you go around the circle once, the answer when you go backwards around the circle, the answer when you go around the circle 17 times. You know what I'm saying here? So because of this, you can try to solve using the inverse sign, but I like this way I phrase this here. The calculator will give you an answer, but it may not necessarily give you the one you want, or if you want to add on to it, it may not give you all of the answers you want. You were doing this yesterday when we were talking, because you were just doing the inverse sign, which there's nothing wrong with that. If I were to ask you when sine of theta equals 0.5, nothing wrong with going inverse sine 0.5. Let's do it in degrees, though. Degrees will be a little bit easier to see. Nothing wrong with going inverse sine 0.5 and saying, hey, look, it's 30. But is 30 the only answer? No. There's also 150, 390, etc. Right? So you have to be smarter than your calculator when you do that. So I said you can use the Castellan reference angles. You could use a general solution. You can also intersect on your calculator. But you have options here as well. Just don't just do one odd thing in your calculator and say, oh, that's the answer, because there's more than one probably. Let's do these ones here. Let me skip to this one here. I'll just do one of them. Let's solve for theta when sine theta equals negative 0.623. So let's walk through some options. Option 1, I could just go inverse sine negative 0.623. Okay, there we go. I got an answer. I got an answer. I got, let's call it negative 39. Does that work? So negative 39 degrees is an answer. But what if the question said it wants only the answers between 0 and 360? Well, those aren't between 0 and 360, are they? So there's some other ways we could approach this. We could draw a grid here and go with the cast rule. And I could say, well, where is sine going to be negative? Sine would be negative in this quadrant here. Well, actually, that makes all the sense in the world, right? Because negative 39 degrees would just be going backwards that way. If I went the proper way around the circle, what would it be? Minus 39, go. Yeah. Oh, I inverse signed in my calculator. I went inverse sine of the value there. I'm in degrees. Yeah. You always have to know which one you're in. Because you have whatever that is as like radians. Okay. So once you agree that this is 39, then that's ugly. That's 321. Goodness, come on, Chris. 321. Okay, so 321 is a valid answer. But there's even more answers than that, right? Because there was also a possible triangle in this quadrant here. And if this angle here, again, is that reference angle of 39 degrees, then, okay, what's 180 plus 39? 219. So you could go all the way around to here and get yourself 219 degrees. And if you wanted to, you could just grab a calculator real quick and check them both. So if I were to do the sine of 219, it gives me negative 0.62, close enough. If I do the sine of 321 degrees, it gives me negative 0.62. Again, it's not the exact number because I rounded. We're okay with that? Now, the way this one phrased it here is it said solve for theta, which means we need to find every single theta out there. So the best way of writing this now is with what's called the general solution. So why don't I just write out the general solution for you, and then you can see whether it makes sense to you. That would be the general solution. Either 219, I guess it's degrees, or 321 degrees. But for either of those answers, you could go plus or minus around the circle, which is 360. You could go forwards or backwards. You could go around the circle a million times if you wanted. It'd still work. So that's like one of the ways which we would write a general solution. They all look something roughly like that. There's no like one correct way of writing it, but it usually involves like a plus or minus something n or I. Sometimes they use I. Do you guys know what n and I stand for? N stands for a natural number. Natural numbers are basically whole numbers that are positive. So like 1, 2, 3, 4, and 5. Okay. So if you use n, and n is a natural number, then you need to use plus or minus, because then that means that you need to account for the minus, because naturals are only ever positive, but you have to be able to go backwards too. Another way of writing it, by the way, which would be the exact same thing, would be write this again down here, and then just say plus 360i. And then an I stands for an integer, and then integers are whole numbers that are now negative. So then now the negative is accounted for in the I, so therefore we don't need to write it here. Whatever, it's the same concept. Sound good? Okay, let's try another example. Let's move forward here. Now, this is what I've started to have you guys start to work on your assignment. So, Jamie, I worked with you on a couple of ones similar to this yesterday. So what I've done here on these examples is I've been more specific. I just have only solve for values between 0 and 2 pi. So that eliminates the whole issue of, well, like general solution problems. So there may be 2 answers, but there might be more than 2 or less than 2 depending on how this works. So option 1, when I want to solve this here, you could just literally use your graphing calculator. You could type this whole blooming thing in the calculator and just solve it. 0.5 cosine x minus 0.5. Right, just type it in. Before I press enter, I just want to consider what the graph should look like. It should look like a cosine graph. What does this 0.5 in front of it do to the graph? Good job, yeah. Squishes it down. And then what does the ending 0.5 due to the graph. So it's been squished down, and then it's also been slid down. Okay. Now I do need to check my mode again here. I'm in degrees, so I need to make sure that my window goes to 360. You always got to make that switch back and forth. So now I'll take a look, and it looks like there's my cosine graph. It's lower than it was before, and I don't think it's quite as tall as it once was. You guys get that as well? All right. All I got to do is find out where it's equal to 0. I don't even think I need my calculator to do that. I think it's going to equal 0 right here and right here, which are probably 0 and 360. Or in radians, 0 and 2 pi. So there, I got my answers. I'm going to close that door real quick. You guys able to follow that one? Okay, so that's one option. I mean, it's, I don't know, it is what it is. Option 2, what if it's multiple choice? Actually, I like these ones best. If it's multiple choice and they give you multiple answers, you know what I do is I just take my answers and I reverse engineer them, plug them right back in. I'd go 0.5 times the sine of 360 minus 0.5. Maybe 360 isn't an answer. Maybe I was getting a little ahead of myself. Oh, it's cosine. Duh, Chris. 0.5 cosine 360 minus 0.5. But look, 360 works. Right? So like if it was multiple choice, the fastest, most efficient way of doing it, take the 4 answers and plug them back into the equation, see which ones actually are true. All right, third option, something a little more algebraic. You could actually factor this. You guys see how there's a 0.5 on both of them, right? It means that you could factor it out and make 0.5 bracket cosine of theta minus 1 equals 0. Are you okay with that part so far? Well, what you're left with is something very similar to when we do quadratics. You know, when we do quadratics, we have 2 factors, and the 2 factors each kind of provide some answers to them. Well, when is 0.5 ever going to equal 0? It's not. 0.5 is 0.5, it's not 0. But maybe this thing right here could somehow be 0. So I could write out cosine of theta minus 1 equals 0, or I could say I'm really looking for where cosine of theta equals 1. I factored out 0.5 out of both of these. So when you factor out a 0.5 out of 0.5, there's like a 1 here and a 1 here. Good question. Sorry if I glossed over that too quickly. So what I'm saying here is that either this thing was equal to 0 or that one was equal to 0. Kind of like we would do with quadratics. 0.5 is not going to equal 0. That makes no sense. But the cosine of theta minus 1 could equal 0 if cosine was 1. Where is cosine equal to 1? Here's a cosine graph. Where was it equal to 1? Here. And here. So 0 and 360. Potato ways of doing the same thing. Now this one's really sneaky. It actually wanted between 0 and 2 pi, not including 0 and 2 pi. Technically, there would actually, on this one here, there'd be no answer. You know what I'm saying here? Because the answers were at 0 and 360 or 0 and 2 pi, but see how I didn't actually put the or equals to on there? Because of that sneakiness, there actually would be no solutions to this graph. But make sure you're really careful on whether it's inclusive or exclusive. Is that good? Okay, I want to go out of order if it's okay. I want to do C next, just to build up to it. Let's do C next. 4 sine squared theta minus 1. I need to point out what this means, and a couple of you know this already because of my calculus course. If you see a little squared sign right here, it's a fancy way of writing sine of theta all squared minus 1. That's what it means. And the reason why we write it in that notation is that it could be very confusing as to whether the theta is squared or whether the entire sine of theta is squared. See the difference there? So as a way of making sure that you don't accidentally write this one here, because what you don't want to do is have, like, say your angle be 30, and then you square your 30 and take the sine of it. What you actually want is the sine of 30 and then square that. There's a big difference between the two. So the 2 in this location here means the whole thing is squared. So anyways, backing up a bit here. So let's talk about a couple of ways of solving it. First option, we could graph it. That's valid. Now, when you type it in your calculator, it would have to look like this. 4, open a bracket, sine x, close a bracket, close a second bracket, and then square it. See how that's the way that we're going to square the entire sine x bit? And then subtract 1. And then before I press graph, I want to think about what it should look like. What's that 4 going to do to the graph? Make it 4 times $. What's the minus 1 going to do? Slide it down 1. And the squaring part is going to make it so that anything that was negative, when you square negative stuff, it becomes positive. And I think you already saw that one because I showed that to you. Other of you guys get to the one where you have to do the squaring in your assignment? You're just getting to that one. What ends up happening is rather than your graph going like up and then down and up again, if you square it, it goes up, down to here, and then it just pops right back up again because you can't have negative numbers. So, last thing, I'll make sure I'm in degrees and 360. Let's try it. There we go. How many answers are there? Yeah, because look, we're looking for it equals 0, right? Hopefully you can visualize that there's actually 4 x-intercepts on here. So all you'd have to do is just use your calculator and solve for the 4 x-intercepts using calculator abilities. So I'll just find one of them, and then I'll assume you guys can find the rest. So there. There. One of them's at 210. If you guys solve for another one, just let me know and I'll add it to our list. I got 210. Well, 150. Anybody else? Starting from scratch. Okay. Never mind. Yeah. And I think the last one's 330 just to save you some time. You guys could find that with your graphic calculator. You possess that ability? Okay. Well, let's move on to another option. Sorry, Michael. Another option is solve it algebraically. You know how on this example right here, I kind of did some factoring and some solving? I could kind of do the same thing here. I've actually got 2 ways I could solve it. Here's the first one. I could take a 4 sine squared theta and make it equal 1. See how I'm bringing the 1 to the other side? Then I'm going to divide both sides by 4 to give me sine squared theta equals 1 over 4. Okay, well, that sine theta is though squared. To undo a square, you have to square root both sides. So if I square root both sides, you get sine of theta, but it equal, well, when you square root 1, it's 1. When you square root 4, you get 2. Sine of theta is 1/2. Except, you know, when you square root, technically there's a positive and a negative half to the square root. So it means I need to look for where sine of theta is positive 1/2 and negative 1/2. Well, then maybe I go to my unit circle. And this actually explains why there's 4 answers. Because, according to the cast rule, sine is positive up here, but it's also negative down here. It's actually in all 4 quadrants. And if you go through the whole process of figuring out where it's 1/2, opposite over hypotenuse, opposite over hypotenuse, negative opposite over hypotenuse. In all of these cases, I think it's 30 degrees. So then you can find your angles that way. Once you find them in degrees, then just put them into radians if you want. So the last thing we have to do then is actually put these into radians then, because I believe it asks for them between 0 and 2 pi. So the more you do this, the better you get at it. Anyone memorized what 30 degrees is in radians? A sixth of pi. 45 is a fourth. Anyone know what 150 is? So you could even like kind of draw it out over here. If this is the first sixth, it's 5/6.
Oh my god, why do I keep saying quarters?
Because here's the first sixth of 30, then 60 is 2, 90 is 3, 120 is 4, 150 is 5/6 of pi. And then 6/6 is flat at 180. So then this guy down here's got to be 7/6 of pi. You got to skip one, skip another one, skip another one. The last one is the last six before you fit the full circle, which is 11/6 of pi. Or if you really want to, and you absolutely stuck, and you're like, oh my goodness, I can't remember how to convert, just do this. 330 times by 2 pi over 360, and do that sort of thing that I would have shown you on like the first day of the unit. You have so many options. Okay, let me show you one more way of solving this, just in case 3 isn't enough. Let me rewrite it out again. It was 4 sine squared theta minus 1 equaling 0. This was actually a difference of squares. See how you have two different terms? They're both square rootable terms, and there's a negative between. So as a difference of squares, this is actually going to be 2 sine theta, because that's the square root of 4 and sine squared, right? And then one of them is going to be plus 1, and the other one will be 2 sine theta minus 1 equals 0. So there's another option. We kind of came across this a little earlier today already. It means that either this guy is equal to 0 or this guy is equal to 0. So I just have to solve one at a time. Let me know if I lose you here. This then means that 2 sine theta would have to equal negative 1. And if I divide by 2, it means I'm looking for where sine of theta equals negative a half. This one right here means we need 2 sine theta to equal positive 1, right? I'm bringing that to the other side. And then I divide by 2. So it means I'm also looking for where sine theta equals 1, positive a half. This is the exact same point that we just got to a little while ago, right? If we're looking for where sine of theta is the positive a half or the negative a half, those are the different quadrant triangles, then just draw your unit circle and solve. Or use your graphic calculator. There's so many different options there. You could, don't forget, just do inverse sine. Let's not do it here though. You could do inverse sine of 0.5. As soon as it tells you that it's 30, well, now you know how those triangles go. So then the 30s go here, 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 and here, and then you now can find the angles the rest of the way around. So, okay, you guys good on that one? Okay, let me do 2 more, and then I'll call it a day. I'm going to do the middle one I skipped. Okay, the middle one that I skipped is kind of like a quadratic trig function. In terms of terminology, if you ever hear the term second degree function, this is an example of a second degree trigonometry function. You guys have heard the word degree before, right? Degree is like the largest power. It's possible to deal with things that have sines squareds plus sines plus constants. So in a way, think of it like this. This is really 2x squared plus x equals 1. I'm changing out sine for x. Pretend there's no signs there, just pretend it's just variables. 2x squared plus x equals 1. Well, how would you have solved this if there was no signs involved? Yeah, subtract 1 from both sides. It's now a quadratic equation. Okay, well, how do you solve a quadratic equation? You have your formula. You can also factor, by the way. this one factors quite nicely. It's a 2x squared plus 2x minus x minus 1. Cut it in half. 2x, x plus 1, minus 1, x plus 1. I'll pause there just in case I blew through that too fast. Which means that you've got 2x minus 1 bracket x plus 1, and don't forget the whole time this was equal to 0, I just wasn't writing it the whole time. So what does x equal? Well, this one right here means x equals negative 1, and this one right here means that x equals a half. I should really readapt these slides so that you have more room for that one, don't I? Like writing off the margins. Sorry, guys. Because what ends up happening is this is 2x minus 1 equaling 0. So then you have to bring the 1 to the other side and make it positive 1, and then divide by 2. So then even though this factor is negative, the fraction is now positive. And then this to this one right here. Yeah, so that's why, well no, this is the factor, 2x minus 1. The root is then, if the factor is a negative sign, the root is a positive. I'm losing on this step here. This is where you're lost between these two.
Yeah, so you add the 1 over to the positive.
Right, so then what you end up getting here is 2x equals 1, divide by 2, means that x is positive a half. No. I think, because like say I gave you x plus 3, x minus 2. The fast way that most people know how to do this is they just flip the signs. And you just say, well, if this is x plus 3, then x is negative 3. And if x is minus 2, then x is 2. I think that's what I'm guessing you're thinking here. But the reason why that works is because technically what you're doing is x plus 3 equals 0, and then you're minusing that from both sides to give you x equals minus 3. Right? Now, on this one right here, this x plus 1, I just straight up threw it as x minus 1 because I just could see it. But depending on how you see this one here, see how like the positive one gives you a negative answer? Well, this negative one here should give you a positive answer. I went through the steps of actually adding it to both sides, but don't add the number to both sides, but then flip it again. That's kind of undoing what you just did. Okay, so back to this spot here then. Are we all okay with x being 1/2 and negative 1? Okay, but here's the thing. This wasn't x, this was sine theta. So all I do is I just change this out and I say, well, now I need where sine theta equals 1/2, and I need where sine theta equals negative 1. That's all. I feel like I've done sine theta equaling a half before. Like after a while you get sick of it because you're like, I've done this one already. So, I mean, here's an option. Inverse sine a half, 30. There's a answer. Does that work? We now know that 30 is pi over 6, but that's only one of the answers. Maybe I'd draw like a quick little diagram here, remind me of myself of the cast rule, and say there's one in this quadrant here, but there's also one in this quadrant here. Remember what it was? Which is 5, pi over 6. Good job. Yeah, so this one provides two answers like that. Hopefully you have a couple different ways of being able to solve for them. You could go around the circle a few more times, but I think the top of the question said only between 0 and 2 pi though. So, okay, so this guy right here provides two answers. But this one over here also requires some more possible ways of solving. Now, I mean, here's one option. You could just try to inverse sine negative 1 and see what happens. It gives you a negative 90. Yeah, that's not overly helpful maybe. But maybe here's another way of approaching it. Just grab this guy again. Yeah, thank you. Pink is sine for Peter's one on here. Where is it equal to negative 1? 270, also known as negative 90. What's 270 in radians? Now this is not an in-between, this is literally right on the quadrant lines, right? That'll work, 6 over 4, but we usually write it as 3 over 2. So both work, yeah. So 3/2 of pi would also work. So this guy provides 2 answers, this guy provides the last one. That's one way of solving. Another option. Plug it into your calculator. So here's how you type that in. You'd go 2 bracket sine x double bracket squared plus sine x, and then I'd make it equal to 1. You see how there's this portion right here and there's this portion right here? I'll just find where they literally cross each other. Now I'm not going to go through the whole process of doing the whole thing here. Just make sure that I'm in degrees. If I graph it, I'm hoping to see that this thing will cross 3 times. So it looks like it'll cross once right there. That's probably the 30 degrees. It's going to cross once right there. That's probably the 150 degrees. And it looks like it just barely touches right there. That's probably the 270, which is the 3/2 of pi 1. Let's give you options. The advice I want to try to give you is you need to figure out which option is the most economical use of your time, because it depends on the scenario. Sometimes the graphing calculator is the best choice. And some kids, I think they feel like that's cheating because they're like, I should have to do this algebraically. But I mean, look at the amount of work that you've written down sometimes. Sometimes we hardly write anything down anyways. Like there really is no like true algebraic method. Like you might do a little bit of work here and there, but it's not a ton. So feel free to use any of the methods. So unit circle, graphing calculator. You can inverse things as well. Only inversing only gives you one answer, so be smarter than your calculator. You can guess and check the 4 answers from the multiple choice. That also works, right? Those are some of your main strategies. Sound good? Okay, last one, then I'm going to stop. I promise. This one shouldn't be quite as long. The last one here just says solve using a general solution. I want to do this guy down here, if you don't mind. Secant cubed equals negative 8. Okay, so options. You could try using a graphing calculator. Graph a secant cubed. Graph negative 8, find where they cross. Pros and cons to that. Secant cubed is not an easy thing to graph, because I have to find a way to graph it with the cube sign, and then a secant really is a cosine that you throw a negative 1 on there. So there is a pitfall there, right? So that might not be your best option. Maybe an easier way of looking at this would be to go, well, can't I cube root both sides? What happens if you cube root a secant? Well, you just get a... What happens if you cube root negative 8? A negative 2. Because negative 2 times negative 2 times negative 2 works. Well, this isn't quite as bad anymore. You know how I was afraid of graphing the secant cubed? I could graph just a regular secant and just figure out where it equals negative 2. So that's an option. But maybe while you are going through the process of doing that, here's another option. I know that secant is equal to negative 2 over 1. And if I were to plot that, CAST, it's negative in this quadrant here. It's negative in this quadrant here. That's the hypotenuse over the adjacent. Then I have to go, hey, I know this triangle. I'm pretty sure there's a 60 degrees in there. I bet you that's 120. I bet you that's 240. And I might just be able to figure that out by knowing my triangle stuff, which may just be faster than graphing it. Not that graphing it, there's anything wrong with it. Gotta double check. 1, 2, root 3. Yeah, 60 degrees is the one between the 1 and the 2. Here's another option. Now, I can't actually inverse a secant, but I could do a cosine. If secant is negative 2 over 1, then cosine would be 1 over negative 2. And that one I could use my calculator for and go inverse cosine negative 0.5. Now, the downside to this method, though, is it only gives me one answer. But at least it gets me going, right? And that one answer gave me was 120. Well, that makes sense. This was the 120. Oh, look, there's a 60 left over. That puts a 60 here. That makes that. Makes sense. Okay, so that's my lesson. It's more or less just kind of putting together all of the concepts you've learned. So I like the toolbox analogy. You can use a nail, you can use duct tape, you can use sticky tack. I don't really care which one works. Right? It's your job now to use the skills I've given you to solve whatever question they throw your way. This is where I don't mean to like shirk the responsibility and throw it on you, but like I don't know what they're gonna ask. Right? They can phrase it in so many mean and clever and confusing ways to try to mess with you. So I'm gonna do my best to try to give you as many examples as I can. So why don't you guys take the next little while here and try some of the diploma questions I threw into the last half of the lesson, and then maybe tomorrow we can go over a few of them. Does that work? So you can probably skip the remaining ones we've done here. Like, just go to the diploma ones now. You can take a break first if you want as well. Does a hot tub count as a bath? No, you're not really cleaning yourself.